At this point, we spend a lot of time talking about both difference quotients and limits, and I want to think about how these two concepts come together, specifically in the form of a limit of a difference quotient. So what I want to do now is give a graphical interpretation of this difference quotient and this limit of a difference quotient, noticing that the difference quotient on the left side is exactly the same as the argument of the limit on the right side. So we would hope and pray that these two things are tightly connected in some way graphically. So if we have a graph of y equals x in front of us, how can we, for example, look at the first difference quotient, the left-hand one? The first thing to do is notice that we have, an f of 2 and an f of 2 plus h. So that makes us want to think about the x values of 2 and 2 plus h. So we have one of them right here. There's an x value of 2. And then we don't know what h is, so let's go ahead and just suppose, I guess, that 2 plus h is right here. So there's our 2 plus h. Now that we have corresponding functional values, of course. So there's the point on the graph of y equals f of x corresponding to the x value of 2. And it looks like right there is the point on the graph corresponding to x equals 2 plus h. And then, of course, we can look at functional values, so it looks like f of 2 is about right there. And f of 2 plus h looks to be about right there. Good. So notice that these 2 points on the graph of y equals f of x determine a secant line. So if we draw a line between them, we have a secant line to the graph of y equals f of x passing through this point, which is 2 f of 2, and this point, which is 2 plus h, f of 2 plus h. And if we wanted to find the slope of this line, well, the slope is just going to be equal to rise over run, right? And in our case, the rise, if we look over at the y-axis, is just the difference between those two y values, and the run, of course, is just going to be the difference between those two x values. So what are the differences between the y values? Well, we have f of 2 plus h minus f of 2. And what's the difference between the x values? Well, it's just h. And we said this was the slope of a secant line, so I'm going to denote it with an m like we usually do for slope, and then subscript it with secant. Now notice that this quantity that we've claimed is the slope of the secant line is precisely the same as the first difference quotient up here. So that tells us that we know what that quantity is, and we can go ahead and write it down. So this is the slope of the secant line to the graph of y equals f of x between what 2 points? Well, between 2 f of 2 and 2 plus h f of 2 plus h. That's precisely what this quantity right here is. Now, notice that our second quantity is exactly the limit as h gets small of the first quantity. So that says that this quantity right here is equal to the limit as h goes to 0 of the slope of the secant line. So this interpretation allows us to look at the graph and see what's going on here. So if we do look at that graph and think about what it means for h to get small, well, remember that h is just the distance between our x values. So what does it mean for h to get small? It just means that the difference between our x values is getting small. So that just sort of amounts to taking smaller and smaller and smaller h's until we get just right up close to where the x value of 2 is. Well, what's going on then with our graph? Well, we're going to have, different points on the graph. They're going to be approaching the point 2f of 2. And I won't draw all of them, but if you think about the secant lines passing through our first point in each of those, you sort of see a trend, right? What's happening to those lines as h gets small? Well, it appears that those lines are approaching this line, which is the tangent line to y equals f of x at x equals 2. So that is precisely what our limit's going to give us, is that the slope of the secant lines approach the slope of the tangent line. So we can write it out in words. This quantity is going to be the slope of the tangent line to y equals f of x at the point 2, f of 2. And this thing, of course, is uniquely defined. That is what this limit is going to be.